Data flow refers to the movement of information between two or more points within a network or computer system. This involves several stages and different types of transmission methods, depending on the architecture. There are local, wide-area networks, cloud environments, to name a few. In the context of IT, data can flow through local transmission. Data moves between components of a single system, CPU, memory, storage, etc. Network transmission, data moves between systems across physical or wireless networks, e.g. Ethernet, Wi-Fi, or the Internet. The flow of data is managed by protocols such as Transmission Control Protocol, TCP, Internet Protocol, IP, and various security protocols like Secure Socket Layer, SSL, and Transport Layer Security, TLS. Data at rest is inactive data stored on hard drives, servers, databases, etc. While it is not actively being transmitted, it requires encryption and secure access controls to protect it from unauthorized access. Data in use is data actively being processed by applications, often in RAM. The risk here is higher because attackers can access this data while it is being processed. Therefore, encryption during computation and secure memory access are important. Data in transit is data being transmitted over networks, either within a local network or across the Internet. This is more vulnerable to interception, eavesdropping, and tampering. Secure transmission techniques like SSL, TLS encryption, VPNs, and IPsec are used to ensure that data is secure during transit. The data's behavior changes based on its location, at rest, in use, in transit, and how it is handled by the system. Data in a computer system is data within the boundaries of a single machine or device. It may include data stored in files, databases, or held in temporary memory, RAM. Security measures within a computer system include file system encryption, access controls, and operating system-level defenses like antivirus software and firewalls. Data across a network is data that is transferred over a network and therefore faces additional risks such as interception, man-in-the-middle attacks, or routing errors. Securing data across a network often requires encryption protocols, e.g. TLS for web traffic, and network security measures such as firewalls, intrusion detection prevention systems, IDS, IPS, and VPNs. Access controls can be applied at a role base and should include multi-factor authentication. Segmentation can also prevent access to particularly sensitive data within a network, and data integrity checks can add an additional level of security. It is important to also consider physical security to ensure access to servers or data access points is not given or accessible to unauthorized persons. Security strategies depend on whether the data is at rest, in use, or in transit. Some guides for securing data are: data at rest, encryption, ensures that even if unauthorized parties gain access to storage, they cannot read the data. Backup and redundancy, ensure data is safe even in case of hardware failure. Access control, use strict access control mechanisms to limit who can access or modify the data. Data in use, in-memory encryption, secure sensitive data stored in RAM. Secure enclaves, use hardware-based secure environments, e.g. Intel SGX or ARM Trust Zone for executing critical data processing tasks. Application-level security, ensure that applications themselves have proper security hygiene, e.g. safe coding practices to prevent buffer overflows. Data in transit, use strong encryption, SSL TLS for web traffic, IPsec for network communication, or VPN for secure tunneling. Use secure communication protocols. Ensure that the right security protocols are used for data exchange. Regular auditing. Check for vulnerabilities and implement intrusion detection systems, IDS, IPS.